Hello. This is the highest awarding mark question in this paper. Make a guess, how much is this? This is 15 marks, so let's dive in. Let's not waste time. It's all about rate of reaction, and you even need to draw tangent, which is coming out 2 years in a row. So you need to know what's the trend, isn't it? Okay, so with this rate of reaction question, we have a standard carbonate with acid reaction, and they show you the setup. You will be able to see that the cotton wool plug is there. That basically means the carbon dioxide gas that is given out. You can see the product of this carbon dioxide gas is going to escape from the cotton wool. Okay, so this is the main idea, and there are some information. They've given you the mass of calcium carbonate, that's 5 gram, and then you have some volume of acids. Okay, so I'm going to write this down, 5 gram over here, and this will be linked to the first question of mole concept. Okay, so the reading of the balance decreases as carbon dioxide gas is lost through the cotton wool plug. This is to give you the context, okay, to help you understand, but basically this is what it means: all the carbon dioxide were escaped. Okay, so they want you to calculate the mass reading of the balance when the calcium carbonate has reacted. Now you've got 5 gram of calcium carbonate, and they say that all of it is going to react. I'm just going to write it down with a thinner or finer pen. Okay, 5 gram. Assume all the carbonate gas is lost through the cotton wool plug. So how do we go about doing this? You are given this mass, so that basically is your limiting reactant. It's going to finish, going to be completed, it's going to be used up completely, and all of it will form carbon dioxide. Okay, so you're going to find a relationship between these two. So the first thing you want to do for any mole concept question is to just draw out the triangle mass, mole, and then followed by AR or MR. The main difference between this is AR is for element, like for example the mass of sodium is 23, okay? MR is really for molecule or compound, so like for example H2O, the mass of it is 18, okay? So the first thing you want to do is to find out the mole of calcium carbonate. So to find mole, we want to use mass divided by AR. So we're going to write this down for the first time. Mass divided by the MR in this case, and it's very nicely given to us based on the question. It's a very nice number of 0.05 mole. Okay, so that's step number 1. Then step number 2 is you want to find the relationship between calcium carbonate and carbon dioxide. What is the relationship? Basically, what is the ratio? Okay, so we're trying to look at the number before the equation, before the chemical formula. So this number here is what we call stoichiometry. It's just a fancy word, but basically it's referring to the ratio between calcium carbonate and carbon dioxide gas. Since there's no number in front, what it basically means is the ratio is 1:1. So for every 1 mole of calcium carbonate that is produced, you actually get 1 mole of carbon dioxide. Okay, so based on our first step, if we only have 0.05 mole of calcium carbonate, that means the maximum number of mole of carbon dioxide that can be produced is also 0.05. So the third step here, because based on the question, you want to find out the mass. Okay, you want to find out the mass that is left on the balance. So you want to find out what is the mass of carbon dioxide that is produced. So you want to find out mass of carbon dioxide that's produced. What you need to do here, you use mole multiplied by the MR. Okay, again the MR is provided in the question. For carbon dioxide is 44. After a while, you will actually start to remember common MR like water, carbon dioxide, calcium carbonate even. It's very easy to remember, right? Because it's 100. And what you do here is you end up with a mass of 2.2. That means 2.2 gram is lost through the escaping of carbon dioxide. So then, what is the remaining mass that is left on the balance? It's very simple. You just use whatever number that you see on the balance right now, which is 122.2, and you minus that 2.2 gram, and you end up with a very nice number of 120. Sometimes when the number is so nice, it's almost like I definitely get this question right, isn't it? Okay, so there's 3 marks there. Okay, next question here is graph plotting. You need to show time versus mass of carbon dioxide produced. Okay, so with graph plotting, I would recommend definitely trying a few rounds using graph paper, freehand, and it should be a smooth curve. Okay, one thing to take note is it must be a smooth curve. Don't draw things like that, so you get all the weird lines or the gaps in between. So you got to work on drawing one smooth curve. Ideally, I prefer 2B pencil over mechanical pencil for the ease of that smoothness, in my opinion. Okay, so if you can do that, drawing a line of best fit through the points, you will have gotten 1 mark. And then the first 3 has been, so the rest is just mainly plotting. So basically all the red color crosses that you see over here, those are worth 1 mark as well. Okay, so work on that plotting. Next thing is tangent question. Now I've noticed for 2 years in a row, last year 2024 and this year, they like to get students to draw a gradient of tangent. And why is it so? So I went through the entire syllabus and I looked through the syllabus, and they mentioned that they actually require students to be able to draw the slope of gradient and use that gradient to calculate rate of change, and that is for both physics as well as for chemistry. So like 2 different subjects, but they require same thing. So it seems to be a trend, so take note of that. Okay. So how do we do it? Okay, so they want you to draw a tangent, or calculate a gradient of the tangent at the 2 minutes. So you need to go to your 2 minutes, look upwards, okay? And then that's what I've drawn. I've drawn the green line. But make sure before you draw your horizontal line, you want to place your ruler at an equal distance from the curve at both ends. I would think this is emphasized in math, but the same concept apply in both physics and chemistry as well, okay? And so if you're able to do so, then look for 2 points that is neat and tidy and allow you to easily read off from the chart. And for me, it would be these 2 purple dots over here. Oops. Okay, and the purple dots allow me to get a y value. Okay, so to calculate gradient, you always use y2 minus y1 over x2 minus x1. So I'm going to share with you what's my y2 and y1. So it would be this one. Okay, so if I read across, okay, my y2 is 1.88 and then my y1 would be 1.28 over here, and I'll do the same for my x, and I'll read down. Okay, read down, I'll get 1.4. If I read down here very neatly, I like to find this kind of whole number. It just assure me. Okay, and so I end up with this value here, and I just subtract it. I get 0.6 for my y, and the difference of my x will be 2.6. So I end up with the gradient of 0.23. And one thing they want you to take note of here is drawing the tangent. So how do you get the marks here? Let me write it down for you, okay? So 1 mark is to actually draw the tangent, because they want you to draw the tangent at 2 minutes. So drawing of tangent alone is worth 1 mark. And then the second mark is to find and calculate the gradient. So basically doing the calculation. And then the third mark goes into the units. So take note of all these things. Give the units for rate of reaction, but very nicely, they've actually reminded you at the answer area that you need to work out what is the unit. So if you're still unsure about this, you can always go to the table that has been provided for you. So the time is given in minutes, and then the mass is given in grams. So there is no way you should get this question wrong. So you should, even if you don't know how to draw the tangent or calculate, you should at least get 1 mark for the unit over here. Okay? Alright. Then we have a longer question here asking you for the shape of the graph during these 8 minutes. So if I were to go to the graph, and I'm going to take away all those annotations so it won't disrupt your visuals. Okay? We split the graph into 3 sections. The beginning, which is the steepest. And then number 2 is around here, whereby you see the steepness is actually, the gradient gets more gentle, right? Less steep. The gradient is less steep over here, and finally it flattens out, okay, or it plateaus. Okay, so plateaus is just another fancy word for level out or flatten. Okay, you can see how I describe the graph later. Okay, so we have got 4-mark question here on explaining the shape of the graph. Basically, you just need to describe how the graph look like and why. Okay, so you need to talk about the why. And so the first thing, okay, so we want to, okay, so I'm going to split this into two parts of my answers. I'm going to highlight them. So you want to describe the graph. I'm going to highlight this in blue, and then you want to explain, okay, why. So the part 2 is why the shape looks like this. Okay, so part 1 describe, part 2 explain why it looks like this. So first one, so at the beginning you can see that the graph is the steepest. Okay, so you need to mention that in the beginning the graph is the steepest, or you could say at the start. If you find the word beginning is a bit hard, you could say at the start the graph is the steepest. And then you need to talk about why. Now the reason is because the reactant is at the maximum concentration at the beginning. Okay, so you could say that calcium carbonate is in the greatest concentration, or if you find that that's a little bit lengthy for you and a bit hard for you, you could say that there are more calcium carbonate in the beginning, somewhere along that line. Okay, so that will mean that's the result of why the graph is the steepest. Okay, then as the reaction proceeds, that is that we're looking at the second part of the graph now over here. Okay, why is it that the gradient become less steep? Okay, so again, describe the graph first. The gradient is less steep now, and why is that so? Is because there is lesser calcium carbonate. Okay, so some students focus on acid, and in this case, because they didn't emphasize on which one is the limiting reactant, that works as well. Okay, and then finally, you can see that at the end, okay, it flatlines. And how do I know it flatlines? Is you can go to the table, and you should see that the last 3 plots are the same level, one at 1.8, 1.8, 1.8. So it flattens out, it level off. Okay, so how do we describe this? Okay, so we describe this by using this. Okay, the graph level off, or you could say the graph plateaus. You find that these two words are really hard. You could say that the gradient becomes 0, or flat, or horizontal. Those are alternative words that you could use as well. Okay, and why is it then that the gradient become flat? Right, it's because the reaction has stopped. And why has the reaction stopped? Is because calcium carbonate is completely used up. Okay, so that's how you get 4 marks. Here you have how do they, I know there are like so many points here, then they'll be asking like, oh, so how do they give the marks here? How do they award the marks? So they look at it as a pair. Okay, so like for example, the first set of answers, okay, you describe the graph and you give the reason why. This is 1 pair of marks, so this is worth 2 marks. Okay, then for the second answers, you can say that the gradient is less steep because there is lesser calcium carbonate. That's also another 2 marks here. Or you missed out point number 2, but you went up to number 3 and you just basically say that the gradient becomes 0 because calcium carbonate is completely used up. That is also another 2 marks here. So here there are a total of potential 6 marks here. These answers are worth a total of 6 marks. But once you hit 4 points out of the 6, you'll be able to get full 4 marks over here. Okay? Hopefully this has been helpful. And we're going to look into the last 3 marks for this question. So the context of this question here is student repeats the experiment, but now using powder rather than chips. So this is under factors of rate of reaction. The factors, there are a total of 5 factors, and here if you're using powder, we're talking about surface area. So we need to discuss in terms of surface area. So how do we get 3 marks here? So one main thing is, this is the one that students tend to forget to discuss. Yeah, okay, explain the effect of this change on the rate of reaction. So most students know that when we increase surface area, the rate of reaction would increase. But again, first statement is always the one that students tend to forget. Maybe they are in a rush to explain which comes under point 2 and 3, that they forget to explain in general what actually happened to the rate of reaction. Okay, so it increases. That alone is your first mark. Okay, then you go on to explain. Basically, you tell us the why. Why is it that the rate of reaction would actually increase with increased surface area? It is because there are more exposed surface areas. So you need to take note of these keywords. Okay, it is bolded and highlighted in the examination in the mark scheme. So that basically means that students tend to forget this word. They talk about so that I would think this is the one that you need to really have in order to score for point number 2. Okay, so this will increase the frequency of effective collision. Therefore, the rate of reaction increases. Okay. Another word for effective is successful. Okay, so thus the frequency of successful collision will increase as well. If you don't like this wording, another way to word it would be there will be more collision, more effective collision. I would say more effective collision per unit time. So the word per unit time here, is used to replace word frequency. So again, at the end of the day, you decide what phrasing sticks better in your brain, and you try to word it out on your own. Okay. Again, if you find that there are certain wordings that you really stick to you, but you're not sure whether it will be acceptable, feel free to just DM me. I'll be happy to check for you. Okay. So one final warning here is how will you end up losing marks? Okay. Now, if you end up in your explanation, you talk about more energy or the particles move faster, you actually will actually lose marks here. Because why? Because this is caused by increase in temperature. So when the temperature of the solution increase or the temperature of the acid increase, then only will the particle move faster, because the particles will have more kinetic energy. Okay, so take note, do not fall for this. Understand that there are a total of 5 factors, and every factors here, they have different wording or keywords for their explanation. Okay, so hopefully this 15 marks, I know this is a very lengthy video, but this 15 marks is easy for you. And if you find that this is easy, try 2024 paper. Again, I think I've previously done a live on it. And this will give you a little bit of feel of what kind of tangent question they are looking for, or like coming out with probably this year as well in 2026 papers. Alright, if this has been helpful, like and subscribe and share with a friend who might find it useful. See you in the next one.